All right, we got a new unit, new lesson here. The good news is most of this today, probably the next couple days, is just a review from geometry class. The new unit is right triangle trigonometry. So it's going to feel a little bit like geometry. We're going to see a lot of triangles and basically sine, cosine, and tangent is what we're going to start out with in right triangles. You might remember from last year, Sohcahtoa, and I'm going to talk about that stuff right now. So let's say you have a right triangle. Okay, everything we're going to be doing today and for quite a while in here is going to relate to this shape right here, the right triangle. Okay, meaning it has a right angle in it. It's a triangle with a right angle in it. And what happens is we're always going to be, so the right angle is the right angle, but there's always two other angles. And every problem will kind of focus your attention to one or the other. So for example, let's say we want to focus on this angle up here. And sometimes they'll have a letter there. You can call it angle A. Sometimes we'll just call it angle A because it was, the point A was right here. Other times they'll just put an actual letter in here or even a question mark or something just to get your focus on what they're talking about. So let's call this is the Greek letter theta. At least that's a sloppy version of it, but basically like a little circle with a line through the middle. Theta, okay? So let's make that our attention. Totally could have been down here, but we'll focus up here as the angle that we care about, okay? And from this angle, it's always about where I'm coming from. So from this angle, there's three sides. Every triangle has three sides. And from this angle, this would be called the opposite because it's across from the angle. So this is called the opposite side to the angle that I'm focused on. This one over here is called adjacent. Adjacent means next to. So this side right here is next to the angle. So it's adjacent to the angle. Once again, this is opposite over here. This is going to be called adjacent. And you might be wondering, if you don't remember this from last year, why isn't this called adjacent? Okay, it's also this is also next to this angle that we're caring about right now. Okay, they're both adjacent, but this one already has its own name because the side across from the right angle, whatever side is across from the right angle, is called the hypotenuse of a triangle. So we have opposite, adjacent, hypotenuse. Let's put some of that to writing. We'll call this opposite. Most of the time I'll end up just using O for opposite. This will be adjacent. And of course I'll use A for that. And this would be the hypotenuse. And we'll use H. Alright, so who cares? That would be the next question you want to ask. Why do I care? Why do I have to have names for these three sides? Opposite, adjacent, hypotenuse. Because somebody made up some relationship. They made names for the relationships. These three names are sine, we'll call it sine of theta, cosine theta, tangent theta. And I'm only calling them theta right now because that's what I called it right here. So I'm just trying to keep everything, connected. Keep in mind this stuff's made up. Somebody made this up. Somebody said, I want to call sine, and then there's going to be a relationship that goes with that. There's going to be a relationship here and a relationship here that were invented as definitions. And for sine, that relationship is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Those are just definitions in math. And so when you hear Sohcahtoa, it's just a nice little quick way to remember it. That these are the three relationships over here are right here, and that just means this. It's just if you can write this down, you get on your test and you write down Sohcahtoa. Of course, you have to spell it like that with some silent H's and whatever. There it is. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. So this slide right here, in the video, this whole thing is just really not doing any problems yet. I just wanted to give you some reminders of what these definitions for sine, cosine, and tangent are. For the next couple of weeks, we're just going to keep building and building and building, and it all comes back down to this. It all comes back down to this is the basic ideas. So in a problem like this, where really these are going to build up today a little bit, but it stays pretty basic. The question is find the cosine of theta. So now, instead of just being generically saying it's adjacent over hypotenuse, because remember Sohcahtoa, let's write it down real quick again. Sohcahtoa will remind us that cosine, since we're looking for cosine is adjacent over hypotenuse. So cosine theta equals adjacent over hypotenuse. And so for this problem, we have to come over here. We're going to look at this picture. Here's theta. Okay, this is the hypotenuse because it's across from the right angle. Whatever's opposite of the right angle is called the hypotenuse. This over here, which we don't even know anything about, we don't have the measurement here, is opposite. It's across from the angle itself that we care about. And this is adjacent. So this is adjacent, this is hypotenuse. I started us off with a really simple problem because the answer to this is just 6 root 2 over 11. That's it. We need to think about that a little bit. Think about it, but get it straight that the reason I was able to just write this number over this number is because in this problem, this is adjacent, this is hypotenuse from this angle, and that's what they wanted, was cosine, which is adjacent over hypotenuse. Simple problem. This next one's going to be a little more interesting because you don't get a picture. So for starters, there's no picture. You just have all this information. You have to create your own picture. Everything today is going to be about right triangles. So, when there's no picture, just draw a picture. That's probably the simplest way to do this. And start by drawing a picture of a right triangle. That's the key. They're all going to be right triangles. You'll notice that they're asking for sine of A right here. So let's put an A in there. We could have put it wherever. I mean, I have my right angle over here, and then these will be the A and the B. It even says in the problem, and you'll see this on the homework, it's just reminding you that C is the right angle. I guess it doesn't have to be, but that's usually how we label it. So C will be the right angle, and that would make maybe call this B. So we got a triangle called ABC. Next thing you need to know. It says B equals 4, little b. Well, we're going to always call our angles, or our points on the triangle here, capital letters. And therefore, across from the capital letter, this is just something you need to know. It's a pretty standard thing. Across from the big letter is what we'll call the little letter that goes with that. So you have your little b goes with your big B. Your little a is going to go with your big A. So in other words, what I'm saying is this is going to be the 4 and this is going to be the 3. The question is, what's the sine of A? Okay, this is A right here. Well, sine is opposite over hypotenuse. Okay, opposite over hypotenuse. So in order for me to answer this question, I will need this side. It's going to be 3 over that. So in a lot of these problems, you end up using the Pythagorean Theorem, which is when you have a right triangle, a squared plus b squared equals c squared. And where c is always the hypotenuse, the one across from the right angle. So we have 3 squared plus 4 squared. Let's go ahead and call it c squared. We'll call this the c right here. So that's 9 plus 16. That's 25. And then we're going to square root and get 5. And you notice on these, I do not do plus or minus. It's not plus or minus 5 because we're dealing with the actual triangle. It only has positive lengths. We can't have a negative length for this triangle. So now that we know that c is 5, we can say that the sine of A equals 3 over 5. Remember sine is Sohcahtoa, so S-O-H, opposite hypotenuse. Look back at your notes, and you remember that. I don't want to write it every single time on this video, but I'll write it maybe once or twice more. But for this one, I'm just reminding you it's opposite over hypotenuse, 3/5. All right, here's another variety of basically it's all going to be the same ideas today. I've just tried to pick a problem, each type of problem that you're going to see in the homework, even though they're all basically doing the same thing. So this one here, for example, once again, I have no picture. Some of these have a triangle given to you. Some of them just give you information. When that happens, make your own picture. So in this case, always going to be right triangles. So make a right triangle. Maybe put a theta in there, because you see that the problem's being labeled with all these theta stuff. We're looking for sine, but we want to start with what we know. We know cosine of theta is 3/5. So that means that the adjacent over the hypotenuse is 3/5. This is 3, this is 5. This is over here is opposite. I don't know anything about that. I just know cosine of theta is 3/5. So I know that this is 3 and this is 5. The question is, find sine of theta. Well, in order to do that, I need opposite over hypotenuse. Remember, Sohcahtoa. Just keep coming back to that. Keep going back to that, because the reason I put the 3/5 in here was because I know cosine is adjacent over hypotenuse, adjacent hypotenuse. I want sine. I know that's opposite over hypotenuse. I need this side. Once again, we're going to do 3 squared plus, let's go ahead and call it, we can call it whatever we want here. Let's call it x or whatever. So 3 squared plus x squared equals 5 squared. That's 9 plus x squared is 25. X squared equals 16. Square root, you get 4. Notice that pattern there. You don't always have to do all this Pythagorean theorem work over here. If you know that every right triangle that has a 3 and a 4, the hypotenuse is 5, or if there's a 3 and a 5, that makes this 4. This is the combination for Pythagorean theorem of there's a 3, 4, 5 triangle. So if you have 2 out of the 3 things, you can automatically know what the third one is. So we found that x is 4 over here. So don't forget, what we're really trying to do is we're trying to say that sine of theta equals 4/5, because opposite hypotenuse. All right, now we get into something probably a little more meaningful. We're actually going to use sine and cosine. We're going to need our calculators a little bit for these. What if we have an actual angle in degrees given to us? We have a side, and we're looking for another thing. We're looking for another side. So this is where this gets, I think, a little more fun. Here's the deal. We are here. Since they've given us this angle, this is our theta or whatever. This is the spot we want to focus our attention on. We want to think of ourselves up in this corner looking out at this triangle. From here, this would be opposite, and this would be adjacent. And of course, this is the hypotenuse. Notice that the 2 things I care about in this problem, the 2 sides that I care about, are these 2. I care about them because I need to find this one, and I know this one, which is going to be helpful for me. I don't care about this side over here at all. I don't know it. I don't need to know it. It means nothing to me. These are the 2 that matter. So from this angle, this is opposite and this is adjacent. When I'm thinking about my Sohcahtoa and I think about what 2 sides I care about, everything's pointing to me to this. It's right here. Tangent. This problem is going to be using tangent because, once again, from the angle that's given, the 2 things that matter to me, one of them is opposite of the angle and the other one is adjacent to the angle, where this is the hypotenuse and I don't care about it. I don't care about it because nobody's asking me to find it and I don't know what it is. It's not important. These are important. So tangent. Write down tangent. Put down the actual angle this time. We actually know the tangent, where we're looking for we know the tangent is 52 degrees. We know the angle is 52 degrees. So we're taking the tangent of 52 degrees, which I'll show you how, that's just a number on a calculator. And we know that when we do that, it equals x over 4. So we go x over 4. Now, the next thing we need to do, the calculator will tell you what the relationship is for tangent of 52. It'll tell you what the opposite over adjacent decimal is for 52 degrees. So there's a couple things. I'm not going to pull up a calculator obviously right now, but we can work on it in class. But I think you can handle this just by me telling you. Number one is you need to hit the mode button in your calculator just to make sure. If you hit mode, and make sure you're in degrees. There's another we're going to do later is called radians. We want to be in degrees, not radians. So we don't want to do this, we want to do this. So just scroll down, move your arrows over until it says degrees. Otherwise you're going to get wrong answers. So once you've done that, you can get out of there, and then all we're going to do now is on the calculator you're going to type tangent, the button tan, and then you're going to type 52, and then you're going to hit enter. And if you did it right, it's going to say 1.2799. So that means that this number is this decimal right here is tangent 52. So I'm going to put 1.2799 equals x over 4. And then I'm going to get out, I'm going to leave this number that's sitting on my calculator right there, and I'm going to multiply it by 4 to solve for x. So if I do that, I get x. And this is all approximate. I really shouldn't be putting equals there. It's all approximately. And you should get about 5.119. And if we round properly, if I'm going to do 4 decimals, let's say, it would be 8 because it's 7/6. So this is a little more useful problem. What you just actually found something. We actually found a missing number. Instead of, if you go back to some of the other problems, we were just kind of showing that we know the relationships. Here we're using the relationship tangent, using a calculator to get that decimal equivalent of this, and then putting that number in where it used to actually say tangent. We put the number there instead, and it allows us to have an equation here that we can solve, and we just found the missing number right here. Here's another. I'm just trying to give all the different samples of things that can happen. This one here is more of a calculator thing also. I just need to show you how to use the calculator for this. They want you to find the angle that when you took the cosine of that angle, it would equal 0.5446. So we're not trying to find the cosine of 0.5446. We're trying to find what angle would give that. To do that, we're going to hit second, and then cosine, and then 0.5446. Because we're doing it backwards. We're not trying to find the cosine. I'm going to say it again. We're not trying to find the cosine of this. We're trying to find what would, when we type the angle in here with cosine, would spit out that value. To do that, we're doing it backwards, so we hit second cosine. And if you do that, you can do it with me right now, hopefully, before you see me do it. Second cosine. I'm sitting here on my calculator making this video. And you should get about 57 degrees. It's pretty much, if it's 57.00, we'll just say they want us to round in the nearest degree, then it'll be 57 degrees. And for fun, you could even go backwards now that you think that's the answer to this problem, 57 degrees, go ahead and take the cosine of 57 degrees, and it should spit out, of course, this decimal right here. I'll go ahead and do that too on my calculator. if I just hit a pure 57, it's going to spit out 0.5446, and then it goes to 39035, whatever. So we got the idea here that yes, that when you put that number in there for cosine, you do get that. But when I didn't know it, I had to do it backwards, so I hit second cosine to get the decimal in the first place. I mean, to get the angle in the first place. So this is the same idea. We're looking for an angle in a triangle. We have two sides. So this is the angle that matters. This time we don't want any sides. We have two. And nobody's asking for this one. So we have all the sides we need. We need this angle. So from this angle, the two things that are important to us, because what I'm trying to do right now is I'm going to try to figure out which of these things matter. Is it going to be sine, cosine, or tangent? From this angle, the two things that matter to me are the 27 and the 31. I know both of them. I don't need to know this. I know these. It's going to help me find this. These are important. From this angle, this is adjacent and this is hypotenuse. What I don't care about is the opposite side. Well, sine has opposite in it. Tangent has opposite in it. Those aren't it. It's going to be cosine this time. So we're going to do cosine of, I don't know, equals 27 over 31. Well, that's just a decimal. It's just a number. So really it's cosine of, I don't know, is approximately, and then now just typing 27 over 31 on my calculator, I get 0.870, whatever. It doesn't even matter, because watch what we're going to do next. We're going to now, it's just like the last problem, I want the angle that creates this decimal. I don't want the cosine of 0.87 whatever. I want the angle that when I take the cosine would equal 0.87. Well, that's a backwards thought, so we use second cosine. So we hit our calculator, we hit second cosine of answer. So you could retype all those decimal places, or you can just hit second, the negative sign down there, which is answer, and it'll give you about 29.4, and then we'd say degrees. We'll just call it question mark again. And this is, of course, an approximation. So we just found the angle that goes here. It's about 29.4 degrees. I think on the homework it says to the nearest degree. So if it was to the nearest degree, then you just do, which is approximately 29 degrees. All right, one more. Now this one here, I might not even, we'll see if I do the whole thing. This video is going to get too long, but solve the triangle. We at least need to know what that means. It's simple. Solve the triangle means find everything about that triangle. Every triangle has 6 things. It has 3 angles and it has 3 sides. So right now we have 3 of the things. We always have this angle. We're not doing anything unless there's a right triangle, so we don't need to find C, obviously. We have it. It's 90 degrees, angle C. We have an angle right here, angle B we'll call that, because it's next to the point B, and we have the hypotenuse given to us as 10. But we don't know what this side is, we don't know what this side is, and we don't know what this angle is. So let's start with the easy stuff. Angle A. Every triangle adds up, the 3 angles of a triangle always add up to 180 degrees. So if this is 90 and this is 55, just subtract those 2 numbers from 180 and you'll get angle A. So we'll be done with that. So it's just 180 minus 90 minus 55. So angle A is 35 degrees. So you can write that in there or whatever. Okay. So we got that. Angle, well, we found all the angles. So how about side? Let me label this here. This is going to be called side B and side A. Remember, when you have across from letter capital A, it's nice to keep everything organized by calling the side across from it little a, and the side across from big B, call it little b. And we can find any of these. So let's say we want to find, we'll start with a. So we'll start with a over here. Okay. So we can either use, remember I said earlier that where are we at with, what angle are we going to pretend we're at? And it doesn't matter. The problems are going to work out either way. Let's go ahead and go with what we had given to us originally, which was 55. From 55, if I want to find a, then the two things I care about are a, of course, because I want to find it, and the 10, because I know it and it's going to help me find a. So the two things I care about from 55 are these two things. And from 55, this is adjacent and this is hypotenuse. So if I'm going to do this way from 55, then I'm using cosine because this is adjacent and hypotenuse. So it's going to be cosine 55 equals a over 10. Then you get out your calculator to find the cosine of 55 degrees. Now we're back to just typing on the calculator cosine 55. So hit cosine on your calculator, 55, enter. That's what I just did. I typed cos and then 55, enter. And when I did that, it gave me 0.573, let's see, we'll round it to 6, equals a over 10. And then to solve, all we got to do is multiply by 10. We got to cancel out this 10 here, so we multiply by 10 over here, and we get 5.736. And this is, once again, approximate. As soon as we typed it on the calculator, the cosine of 55, it's got a lot of decimal places, and I'm just rounding a certain amount of them. So I really need to have squigglies starting as soon as I get an answer on the calculator. All right, so we found A. All that's left to find now is this side right here, B. And we can still do it from 55. Let's just go ahead and do that. From 55, B is opposite and 10 is still hypotenuse. So from 55, I'm going to use sine. So I'm going to go sine 55 equals B over 10. Remember, Sohcahtoa, sine is opposite over hypotenuse. And if I'm using 55 as my key angle, then B is opposite. And of course, 10 is always a hypotenuse because it's across from the right angle. Get out your calculator again, type sine 55, and then just multiply that number by 10. So remember, sine, I would probably do this all in one step, but I'm just showing you to make sure you got your calculator working right. 0.81915 that's what you should see on your calculator, equals B over 10. And then just multiplying by 10 will give us 8.1915. Let's just stop there. And this is all approximate at this point. And now we've solved the triangle. And now we've finished this video, I think, too. So we have all the missing things we didn't have. We didn't know there was a 35 there. That was something I added in. This was something I added in. And this was something I added in. The three things I had to begin with were, it's hard to know now because I added all this other stuff. So the three things we had were this, we had the 55, and of course we always have the right angle. So that's 6 total things. You see how I've got 3 red circles and I have 3 green circles. That's solving the triangle. Solve the triangle means find everything in that triangle. All right, that covers a lot. That's pretty much a review of geometry, trigonometry, and we're going to build off of this starting next week. So if you need to rewatch anything, do that. Take your time on the homework. Let's get a nice start to a great unit here on trigonometry. Work hard. Be nice. See you soon.